All right, not bad. It worked on the second try. Okay, so here's the warm-up. Find the distance that a particle, Happy Joseph. See, that's what I mean. That's actually, I mean, the J is really close to the Y. Look, it's like encroaching on it. Yeah, spooning it kind of, right? At least they get along, right? There you go. Yeah, there you go. Okay, we'll leave it at that. Find the distance a particle travels around a circular path if the particle, Happy Joseph, makes 22 1/3 revolutions, or 22.3, it's not quite a third, right? 22 3/10 revolutions, and the radius of the circle that it's traveling around is 21 inches. We learned a formula yesterday that y'all memorized that allows us to figure out distance traveled along a circular path. We call that what? Yeah, what do you call the distance something travels along a circular path? Arc length. Good. And we use the obvious letter what? S for arc length. And what is the formula? S is equal to R times theta, where theta is measured in radians. Okay, good. So let's go ahead and plug in what we know. We're trying to find F, the distance it travels. We know the radius of the circle is 21. So again, if you put your units in your calculations, it's a kind of good indicator of whether you're doing it correctly or not. Now for theta, remember, is a measure of rotation, right? We measure it in degrees or radians. But isn't revolutions also a measure of rotation? Yeah, it's just different units. It's revolutions or rotations, same thing. Or laps, if you want to call it that. So I'm going to go ahead and do it like I did yesterday in the second part, when I said we could do the unit conversion in the problem instead of going off to the side and doing it. If I multiplied 21 by 22.3 right now, I would have units of what? Inches revolutions, right? Or revolution inches. That's not a unit of length. So I need to get rid of the units of revolution. So I'm going to put rev down here, and I want it to be what? The unitless measure of rotation, known as radians. Okay? So now, I haven't given you this conversion, but you could figure it out. How many radians and how many revolutions? No. How about one revolution? Not pi. 2 pi. Excellent. Once all the way around. Once all the way around. We already talked about that. All the way around one whole time is 6.28 blah, blah, blah. 2 pi radians. Okay? So that's the conversion that you need. So those divide out, and we're left with inches times radians, which is inches. Okay? So had I given you degrees, you would have converted from degrees to radians, which would have been pi over 180, 180 over pi. Okay? But both of those can be also sent through revolutions. So now we're ready. Now we're not going to leave pi visible in the answer because we're talking about length. We really only want to leave pi visible in the numerator if we're talking about a radian angle. So let's just multiply it all in now. So once we have it written on our paper/iPad, then we type it in. 22. We don't need to worry about the ones, do we? Because that's the identity element of multiplication. So 21 times 22.3. I'll just go ahead and do it. What the heck? Divided by 1 times 2 pi. And I can do it like that because those are in the numerator. 2 pi. And then what the heck? I'll divide by that 1. All right. And you get this right here. And, of course, we report how many decimals? 3. If you report 2, it's wrong. If you report 4, it's not wrong as long as it's right, if they're the correct decimals. All right, so 415 or 416, you can round or truncate. I like to truncate. It saves energy for more math. And if we walk away now, are we getting full credit? No. What are we missing? Units on your final answer. I'm not going to check to see if you have them on this second line intermediately. You should want to put them there for another method of checks and balances. But you really need them on your final answer. Okay. There you go. Now that's kind of a large number. So what if we wanted to put that in a more reasonable unit? What could we do? That's a lot of inches. Do we have another unit that can kind of soak up some of those inches? Feet, right? So let's go ahead and convert that to feet by multiplying by, let's see, inches in the top, so inches goes in the bottom. Feet, what's the conversion? 1 foot is 5 toes, or 12 inches, not feet, yeah. 12 feet would be 60 toes, right? Yeah. For most people. Yeah. Okay. And then those divide out. Now, do I go to the calculator and just type in 2942.415? No, because that's an approximated answer. You got to use the live answer in the calculator, and it's full decimal glory. So the calculator still has it there, so we'll just divide that by 12. And that gives us that. So that gives us 245.201 feet. Okay? So if this were a multiple choice question, even though I give you the radius in inches, the multiple choice answer on the test might be in feet, right? So these are the calculations that you'll have to do. You're going to get really, really accustomed to doing stoichiometry, essentially, is what we're doing here, dimensional analysis, where you're multiplying by conversion factors that are equivalent to 1, and you're dividing out the unwanted units from high to low. You'll be doing a lot of that in this section. You already do a lot of that in chemistry, right? In fact, stoichiometry is kind of a bad word. When I usually bring that up, some people moan, some people throw up, some people faint. We all are doing well so far, right? Stoichiometry. Right? Okay. Cool. Now, that's still a lot of feet. Do we have a larger unit bigger than feet that can soak up some of the feet, like a good piece of bread soaks up the gravy? Yeah, Lisa doesn't like that analogy. Who doesn't wipe up the gravy on their plate with a piece of bread afterwards? That's disgusting. Okay, where my boys at? Yeah, there you go. Gravy. Okay, anyway. Yeah. In fact, the girls, if you don't do it on your plate, that's good. The guys, when they finish it, they'll get another piece of bread, and they'll soak it up off your plate. We're okay with that. What would be the next unit larger than feet? Yards, right? Who uses yards anymore, right? We will. Let's do that. We're just playing around now. Coochie coochie coo, Mr. Problem. I want feet to divide out, and we want yards to come up here. The only time that I use yards is when it's a crossword puzzle clue, and the solution is YWS. In fact, in today's crossword, I kid you not, right there, 51 across, it says fabric mez, which means fabric measure abbreviated. And in a crossword puzzle, when you see fabric MEAS dot and the clue is abbreviated, that means that the answer will be abbreviated. And I kid you not, it's right there, YDS. Yards. Okay? What's the conversion here? Just letting you know. Just letting you know. 1/3. Yeah, I'm surprised. That's great that you know that there's 3 feet in a yard. You know how I know there's 3 feet in a yard? Is because there's 18 Snickers in a yard, and it's all gone. All right. Yummy. Anyway, the feet divide out. Again, the alternative is to have a normal teacher. I apologize. I have one of these at home, but it's halfway filled with Twix. Yeah. Yeah, it's halfway filled with Twix. I didn't buy it halfway filled with Twix. It's just now halfway filled with Twix. All right. And I am also now halfway filled with Twix. Okay. Hi, Autumn. On the count of 3, let's say hi, Autumn. 1, 2, 3. There you go. Hope you feel better soon. All right. So now we'll use this live answer, and we'll divide by 3. There we go. So we get 81.733. I'm into truncating big time. I know. Not the healthiest habit. All right. So that's still a lot of yards. Is there another unit larger than yards? Meters, no. Don't go all metric on me now all of a sudden. Miles? Yeah, we can go to miles. It's not as easy to go from yards to miles as it is from feet to miles. Did you know that? Now okay, well, you're welcome. How many feet in a mile? 5280. If you live in America, you should be culturally literate. Okay? Culturally literate, which means you should know that there are 5,280 feet in a mile, and you should soak up your gravy with bread. Sorry, right, Daro? Yeah. America! Come on, America! We're going to leave it like that. We're going to leave it like that. 81.733 yards. Are you good? You happy with your warm-up? Okay, the whole point of this is to get you comfortable with converting things, whether it's from revolutions to radians, degrees to radians, inches to feet, feet to miles, miles to yards, whatever. Okay? Conversion factors, stoichiometry, it's not that bad. It's actually kind of fun. Emphasis on kind of? Yeah? Okay. All right. So let's just move on to example 3. Once we take a slice of a circle, we can determine its area. Oh, boy. I know you're excited about that. So, have you ever, I'm going to use the new thing. You could snap to a circle. It's so cool. All right? Like when you hold down the line and snap a line, if you draw a circle and hold it, long hold, it'll snap to a circle. I learned that yesterday. What's that? And you can make your own colors. I haven't gotten around to that. Yeah. It doesn't work for rectangles, though. I tried that. And it doesn't work for cats. I tried that, too. See, it doesn't snap to a cat. I tried that. But it works for circles. So let's snap a circle in. Snap. Make it big. All right. So have you ever, ordered a pizza and it was cut perfectly through the middle? No, I haven't either. No. But in an ideal pizza world, it would be cut perfectly through the middle. So let's say you cut yourself, right? Because you got to do it right. You cut it yourself, and you take a slice of pizza out of the circle. Okay? The real name for a slice is called a sector. Okay? It's a sector of a circle. It's a pizza slice of a circle. Now, I know this is a kind of a silly question because I think I know the answer. Have you ever, when you've taken a piece of pizza as a slice like this, as a sector, have you ever wondered what the surface area of that pizza is? Like, not the volume, because that takes into the thickness, but as you stare down at that pizza from the top, have you ever wondered what the surface area of that slice of pizza is? Yeah, I know the answer is all the time, right? All the time. And you may have been like, you know what, I don't know how to do that, and it makes me sad. And so, to help me deal with my sadness, nom, 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 and you eat the pizza, right? And now you feel better, right? Well, we are going to, right here on this example 3, we are going to derive the formula for the area of a sector of a circle, okay? So, here we go. Let us say that the circle has a radius of little r, okay? Let's say then that the central angle of that is theta, okay? Theta. And you can measure theta in whatever you want, degrees or radians. Okay, we're trying to find the area of the beefy brown piece. Any idea how we can derive that? What? Protractor can help you measure the angle. How about proportion? Because isn't it when you take a slice of the circle, you are taking a portion of the area of the entire circle? Right? So when you have proportions, you could do part is to whole as part is to whole, or you can do corresponding parts of the small to the corresponding parts of the big. Let's do that. First of all, let's call the area of the sector, let's just call it A, okay? We'll call the area of the sector A. So let's come over here and set up a proportion. The area of the sector is to the area of the circle. What's the area of a circle? What's the formula? No, 2 pi r is circumference. We're doing essentially small is to big as small is to big. Pi r squared. Good. You should know that. Again, culturally literate. So the area of the small piece, the sector, is to the area of the entire thing, the big circle, which is pi r squared, as the sector and the circle have the same radius, yes? But they both have different central angles. So as the angle of the sector, let's do in radians because it needs to end up like that anyway, is to the angle of the full circle, which is what? If we let this be radians, because that's how we want to end up as, what is the, this is the second time we've done this today, for one full rotation, 2 pi. Good. See that? The part is to the whole. That's another way. Small to big, we're doing part is to whole. That's another thing you can think about. So the part of the angle is theta compared to the angle all the way around for the entire circle is 2 pi. There's a proportion, right? Part is to whole, part is to whole. Well, let's solve for A, shall we? To solve for A, all we have to do is multiply both sides by pi r squared. So it'll divide out on the left, and we're going to be left with pi r squared times theta over 2 pi. And there's your formula for the area of a sector. That was easy. Can we simplify that? Yeah, we can simplify that. Anything good happening there? What's happening to your pi's here? Remember, this is over 1. They divide out. And now the only thing in the denominator is 2. Well, dividing by 2 is the same as multiplying by what? 1/2. So I'm going to call that 1/2 times r squared, times r squared times theta, where theta is measured in what? Radians. Okay? That's the formula for the area of a sector. Now, you don't have to memorize that. You can always set it up with proportions, okay, and do the math each and every time. But it's probably a formula that's worth memorizing, okay? The area of a sector of a circle is 1/2 r squared theta. 1/2 r squared theta. 1/2 r squared theta. 1/2 r squared theta, where theta is measured in radians. Okay, cool. All right. Hey, look, here it is in a box. There it is. All right, super. All right, example 4. Mr. Kilford just scarfed down a slice of his favorite type of pizza. Being a psychology teacher, he loves himself some Freudian pizza. Okay? And again, what the heck is Freudian pizza? Yeah, it involves Freud. Instead of having slices of pepperoni on it, it has little slices of Freud on it. So there's an actual photograph of a slice of Freudian pizza. Okay? You can see kind of Freud has, if you zoom in, it kind of has a little marinara all over his chin a little bit, right? All right. So it's hard to still get Freudian pizza because every time you slice up a little bit of Freud, there's less Freud to slice up, right? He was only one person. Pretty cheesy guy. Yeah. So there's a slice of Freudian pizza. The other thing about this Freudian pizza is when you take a bite out of it, you think about your mother. Yeah. That's like a play on like a Freudian slip, right? When you say one thing but you mean your mother, right? Okay. Freud relates every problem that you have as an adult back to your mother, your relationship with your mother. Yeah, the childhood experiences. Yeah. Okay. So anyway, back to now we know what Freudian pizza is. Don't ask for that next door down here at the New York Pizza Pub. They'll look at you funny and be like, you know how expensive Freud slices are? Come on. Okay? We don't got that. Come on. Mr. Freud is on a pizza that Mr. Kilford just ate. The Freudian pizza has a central angle of 40 degrees. And how do I know that? Miss Kelfer and I are pretty good friends, so he always knows that I'm interested. So he measures the central angle with the protractor that I gave him, which is plastic, so it cleans up easily. If the slice then came from a 14-inch diameter Freudian pizza, A, find the perimeter of the slice that Kilford just ate, and B, determine the square footage, not inchage, but square footage of pizza that Kilford consumed in that single slice of Freudian pizza. Okay, so two things. Now here's the hint. I wonder if this is really going to be a hint. Hint. Someone whose actual foot is actually 1 foot long has a foot that is actually 1/5,280th of a mile long. Okay, fun fact of the day. Yeah. And being Fig Newton Day, here's another fun fact of the day. Had Newton been sitting underneath a fig tree instead of an apple tree, he probably would not have felt the fig fall on his head because they're much smaller, and then he wouldn't have had the realization about gravity, and we would not have gravity today. So, yeah, we wouldn't have gravity today if it was a fig instead of an apple. So, anyway. All right. So let's see what we're going to do first. Let's come over here and just draw on this. What is the radius of this slice if it's cut perfectly through the center? Good. The diameter is 14. The radius is 7. So this would also be 7 inches over here. Part A says to find the perimeter of the slice. The perimeter of the slice would be if you shrunk down and you stood at the vertex here, if you were to walk all the way around that slice of the pizza, how far would you walk? Well, you know for sure you're going to walk 2 lengths of the radius, right? 7 inches plus 7 inches. But you're also going to be walking along this curved path right here. Can we find the length of that? Yeah, that's called the arc length, okay? So let's go ahead and do something here. The central angle here, it said was 40 degrees. Since we're going to use that more than once, I don't often do this. I usually do it in the calculations. But let's convert that to what? What do our angles need to be in anytime we're talking about length or distance? Radians. So we'll put degrees down here and rads up here. And what's the conversion? Pi radians, right, in 180 degrees. Good. So if you simplify, the 10 divides out, and 4/18 simplifies to 2/9. That becomes 2 pi 9 radians. That's the central angle, okay? So we've got it converted. We're going to use that. So come over here now, and we know that the arc length is equal to, of course, r theta. The radius is 7 inches times 2 pi 9 radians, which is unitless. So that's inches units. And so we're ending up with 14 pi 9. Now, inches. Now, remember I said that that's not a very good unit to use, right, Chad? 14 pi 9 inches. But because that's not what I'm reporting as my final answer, I need to use that in a calculation. It's better to store it in that form, or to keep it in that form, I should say, because that form is exact, okay? So now let's go ahead and write it out here. The perimeter, let's call it P for perimeter, not pizza, is going to be 7 inches plus 7 inches plus what we said over here, 14 pi 9. 14 pi 9 inches. That's the arc length. And now notice inches plus inches plus inches. The units are all the same, so they are like terms. We'll just go ahead and type it in. 14 plus 14 pi divided by 9. And it is 18.88. And again, I'm a big truncator, 6 inches. So once again, you don't need to put the units in your intermediate answers like I did on the line above, but it helps. It's nice to get that reassurance that you're doing it correctly. All right, so that's the perimeter of the slice. So far, so good? Okay. Part B asks us for what y'all are always interested in, the square footage. The square footage. Okay. So because this is a sector of a circle, we know we can find the area A of that sector by using what handy-dandy formula? The one we just learned, which we keep in our Backpack, 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 backpack. Right? No, we keep it in our head. What is it? 1/2 r squared theta. Right. Now let's plug in. Working straight down. What value do we use for 1/2? 1/2, right? That's not a variable. And then r is what? 7, I'm going to put inches there, squared, times theta. What was theta? The central angle? No, be careful. 14 pi ninths was the arc length. The central angle was 2 pi ninths. 2 pi ninths, okay? 2 pi ninths. And again, if you had degrees in there, you would have units of square inches degrees, which is not a unit of area. But right now, inches squared is square inches. That is area. So let's go ahead. Since it's area now, we don't have to worry about rounding error because every number in here is exact. We'll just go to the calculator now. And 7 squared, I know that's 49. I'll do that in my head. Dividing by 1/2 or multiplying by 1/2 is the same as dividing by 2. And then times, I guess the 2's could have divided out. Anyway, times 2 pi divided by 9. Yeah, okay, so there we go. And you get this right here, 17.104 inches squared. Oops, that's my playlist. That's bad. That's not a bad playlist. I'm sorry, but I shouldn't be showing that. Not that it's bad music. There you go. So you, like Mr. Kilford can do, you can walk around like Chad, I guess, does too, and just tell people, hey, guess what? Guess what I had for lunch? I don't know, pizza? No, I had 17.104 square inches of pizza. And you're like, you had pizza, Chad. Shut up. All right? Poor Chad. I'm gonna email my friend Chad and say, hey, if you're watching my videos, it's not about you, man. He's like, you have videos? Yeah. Okay? Now, that is another way to measure the slice. We have the perimeter, and we have the square inches. But is it not a fact that pizza slices are 3D? Yeah. So whether you prefer like big time 3D, like Chicago style deep dish, or not so 3D, like the New York thin stuff, it's still 3 dimensions, right? So it's not good to go bragging to people about how many linear inches of pizza you've eaten or how many square feet of pizza you've eaten, right? The true bragging, right, is to tell them how much what. Well, you can tell that's how most people do it. But nerdy math people, they don't talk about the number of slices they ate. They talk about the volume of pizza they've eaten in cubic inches or cubic feet, whatever, right? Okay, so let's go ahead and just do an add-on here. How thick, and we'll make this uniform thickness, not including the crust, I guess, being a little higher. We'll just kind of simplify it. How thick should we make that pizza? Let's not argue like a thin crust, and deep dish, because we all can enjoy it with a Coke. You've seen the commercial. How thick should we make this? Don't say 1, that's too boring. 3, that's my kind of pizza. I'm a deep dish kind of guy. All right. So let's say it's a 3-inch deep dish pan pizza. We now want to figure out the, by the way, I said the square footage. We'll have to come back to that because we found the square inches. But let's figure out the volume. How can I figure out the volume of that slice? Do we need another formula? Do you remember when you talked about geometric prisms like this? All you have to do to find the volume of a geometric prism is multiply the area of the face times what? The distance between the top face and the bottom face, right? A sector, that is a piece of pizza, if we simplify it, it's just a, it's 3-dimensional, right? Well, there, I can't draw 3-dimensional pizza. Eat it. So all we have to do is take the area of the face, which we just found, right, and multiply it by the distance between the top and the bottom, which we agreed on was what? 3. So it should be the 17.104 ... from above, right, inches squared, times the depth, 3 inches. Now look at the units. What is inches times inches squared? Inches cubed, right? So since the previous answer is still live in the calculator, let's just multiply it by 3. And now we have a number that is worthy of bragging, 51.31. And I'm going to brag, so I usually truncate, but for bragging purposes, 312 versus 313, I think I'm going with the 3, right? And they're like, no way! And that's going to be cubic inches. So now you could say, guess what I had for lunch? I don't know, a hamburger? No, 51.313 cubic inches of food, right? They're like, oh, okay. That's like one slice of Freudian pizza. How'd you know? Right? I eat it too. Got it? Can you get all the math that I'm trying to throw at you in all of this? Yeah. Okay, cool. Now, let's go back and do one thing, because I wrote these problems, but I'm not even following my own directions, right? Now, if my wife wrote them, I'd have to follow them. But anyway, we want the square footage. Square footage. This is square inchage. Oh, goodness. I could have done this 2 ways. I could either have converted 7 inches to feet before I plugged it in, or on the back end, I can convert from square inches to square feet. Let's do it since we have our final answer here. That's over 1. I need to convert from square inches to square feet. I don't think I can go straight from square inches to square feet. Okay? But notice that inches squared, that's just inches times inches, right? And square feet, that's kind of hard to find shoes for, right? Square feet. Unless you get these. These are like square-toed boots. I have square feet, I guess. Yeah, okay. That would be feet times feet. You know who else had square feet? Clementine. Very good. Clementine. Herring boxes without topses. Sandals were for Clementine. Did we listen to Clementine in here? Yeah. We did it? Oh, my gosh. Oh, my darling. Oh, my darling. Oh, my darling. It's a song about drowning. It's a song about learning how to swim, actually. But there's this lady in there that has square feet. She's the one that eventually drowns because she doesn't know how to swim. Everyone should learn how to swim, okay? You don't have to join the swim team, but if you fall into foaming brine, like Clementine did, you're going to want to be able to swim out of it. All right, so what's the conversion here? Feet and inches. What's the conversion? 1 foot is 12 inches. 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 All right, I'm out of it. I got stuck there for a little bit. Now, what happens with inches squared? That's like inches times inches in the top, divided by inches in the bottom, and we're left with feet times feet. Okay? So that's one way to do it. You have to multiply by the conversion factor twice. Otherwise, you're doing it this way. 7 inches is the same as 7/12 of a foot. And notice if you plug that in there and square it, what's happening? You're getting 7 squared over 12 squared. Here's our 12 squared, all right? So all we have to do then to convert that to square feet, that's going to leave a mark on my forehead, I can tell. I can already feel it. Now, we didn't store it, did we? I hit myself. Y'all didn't see me hit myself. That's how I got out of that loop. And I don't know my own strength. If we didn't store it, the good news with your calculator is you can go back up there and grab it, okay? And then multiply it by, or divide it by 12 squared, which is also 144. So divided by 12, divided by 12. So that is the same answer from part B, 0.11. And again, I'm bragging, so I'll call it 9 feet squared. All right. I don't know if that number, as it's written here, would incite as much awe when you told someone, right? I ate like 0.119 square feet of pizza for lunch instead of, I ate 17.104 square inches of pizza. And then your friend will be like, are you reporting the volume in square units? And you're like, oh, yeah, my bad. It was 3 inches thick, okay? All right. How are we doing on that? Pizza? Are y'all hungry for pizza? Do they have pizza every day in the cafeteria? Why? Are we? What's it? Oh, it's Rachel's Challenge Day. Okay, we'll stop right there. We'll stop right there. We'll see y'all tomorrow. Be ready for a quiz like what we did in the warm-up. And be ready to find an area of a sector.